So here we go. We're going to look at the lessons here inside of the CompTIA A portal. And prior to this lesson, we had the installing motherboards and connectors and installing system devices. So in lesson 3, troubleshooting PC hardware, which comes before local networking and hardware. So let's take a look at local PC hardware. So here we're starting with the apply the troubleshooting methodology of the CompTIA A plus. We have the topic 3B, configuring BIOS and UEFI settings. And then we have troubleshoot power and disk issues. And then we have topic 3D, troubleshooting system and display devices. So I'm going to go ahead and click on the beginning of lesson 3. And the thing to do whenever you start a lesson in CompTIA A is definitely to check the objectives for the lesson. So with this lesson on lesson 3, troubleshooting PC and hardware, troubleshooting is a core competency for the role of the CompTIA A plus service technician, whether it's trying to identify a fault in a new build or a system assisting a user with a computer that's just stopped working. You will typically be required to demonstrate your troubleshooting skills on each and every day of your job. And that's totally true. And what I want to move into here is the lesson objectives. So here in this lesson, we're going to apply the troubleshooting methodology, which we'll talk about. We're going to learn how to configure the BIOS and UEFI and troubleshoot power and disk issues and troubleshoot system and display issues. And then with any CompTIA lesson, you also want to understand which core exam objectives are tied to the content. So here we have the core 1, because we're still in the first 10 lessons of the course. 5.1, given a scenario, apply the best practice methodology to solve problems. So that's really important, is how to understand the best practice methodology. And that methodology is not only going to come in handy in a troubleshooting, within the course, but also when we're answering the questions for the exam. So we're going to talk about best practices for problem solving and management, and also how to best understand the troubleshooting scenario. So best practice methodology is utilizing the best practices related to identifying the cause of an issue. Troubleshooting starts with the process of problem solving, and important to realize that problems have causes, symptoms, and consequences. And that's an important line in the CompTIA A. Causes, symptoms, and consequences of problems. A computer system has a fault in the hard disk is the cause. Because the disk drive is faulty, the operating system is displaying a blue screen, which is a symptom. And because of the fault, the user cannot do any work. And that's ultimately the consequence. So CompTIA A and the newer version of the CompTIA A are also speaking to many of the impacts of this type of troubleshooting on business and business environments. So here we have from a business point of view, resolving the consequences or impact of the problem is more important than solving the original cause. So what you'll see is questions related to this topic alone, where they're going to ask you, was the result that happened to the business of potentially not diagnosing an issue of the Wi-Fi appropriately, a bigger problem than the actual cause of 100 users down. And you're going to have to basically say, because the consequences was so large, the impact of the problem was more important than identifying the initial cause. So it's really about having that business perspective on the solutions. Problems also need to be dealt with according to priority and severity. The disk issue affects a single user and cannot take priority over other issues with wider impact. And this is an important way to think about IT issues, is to think about how, something that's impacting one user is definitely not as important as something that may be impacting a larger group of users. So I'm going to go right down here, and this gets us into the troubleshooting procedures that are developed in the context of the best practices, methodologies, and approaches. And this is a big part of the CompTIA framework of the troubleshooting method model and methodology, which you'll see referenced as a model and also as a methodology. So the first step is identify the problem, gather information from the user changes, identify user changes, and if applicable, perform backups before making changes. So make sure you have the information backed up so that if you make any changes, you don't lose potential information on a particular device. Begin documentation. So essentially begin describing what type of steps you're taking. Inquire regarding environmental infrastructure changes. So, is there something happening in the environment, like a storm that could knock out the Wi Fi? Is there being work done on a building in a particular location that could impact the connection of an access point? Is there something happening that is potentially causing this issue from another source? Establish a theory of probable cause, question the obvious. So, things that you might assume are not potentially causing the problem are things to think about. If necessary, conduct external or internal research based on symptoms. So, if you're noticing a symptom, you may want to be asking other people if they're noticing the same symptom on other devices, or asking maybe other types of businesses if they're experiencing the same type of problem. So, you're kind of stepping into doing some research. Then, based on what you think is happening, you want to be able to test the theory to determine the cause. And once the theory is confirmed, determine the next steps to resolve the problem. If the theory is not confirmed, reestablish a new theory or escalate. So basically, if you can't substantiate the first theory, develop a new one, or identify the next person that you can have take a look at the issue within your tech team by escalating the issue to someone who has maybe potentially more privileges or access to something to help you troubleshoot. Additionally, you want to then establish a plan of action to resolve the problem and implement the solution. Refer to the vendor's instructions for guidance. That's an important step, basically having that plan to resolve the problem and implement the solution. But you're going to refer to the vendor's instructions because you want to make sure that you're following that for best practices related to that particular product. Now, verify full functionality. If applicable, implement preventative measures. So if you know something is causing the issue, of course, you want to figure out how that scenario from happening. Document the findings, actions, and outcomes. So this is a very important part of this lesson, and also part of the thinking process within CompTIA A, and very important part of when answering questions within the lesson assessment. So here, there's going to be a page here about each specific stage of the troubleshooting methodology. So what I'll do is I'll cover the essential components of each page. So first is identify the problem, and that's about gathering information from the user, asking questions like, what are the exact error messages that are appearing on the screen or coming from the speaker? Is anyone else experiencing the same problem? How long has the problem been occurring? What changes have been made recently to the system? Could there be something that's making a change that's causing the issue? Were these changes initiated by you or via another support request? So changes, who made the changes, what types of impact are those changes making, and how could they be impacting what you're currently seeing as an issue? And are you crossing yourself up with someone who made other changes and you just didn't communicate? If something worked previously, then experiences mechanical failures, it is likely that the problem has arisen out because of some user initiated change or some environmental or infrastructure change. So essentially, something has happened to create the issue because it had success and then now it's failing or not working. So you want to identify what happened to it. Perform backup. So definitely before, taking any next big steps, perform a backup of the data on the device so that if you have an issue with the device during troubleshooting, that data is protected. Let's go to the next part, establishing and testing a theory. So when developing a theory for troubleshooting, if you obtain accurate answers to your initial questions, you will determine the severity of the problem and how many people are affected. So you've done a little bit of research here, a rough idea of what to investigate within the hardware of the OS, for instance, and whether to consider the causes deriving from a recent change, an oversight in the initial configuration, or some unexpected environmental or medical event. So this first level of establishing a theory is where you're starting to develop an idea. You're using your critical thinking skills to think about what is causing it now that I'm starting to look at research and developing a theory. So you're going to want to, of course, conduct research. And you're also, big line here, plausible causes to determine the probable cause. So what is possible and what is probable? You're going to want to conduct research to identify what caused the problem and utilize research techniques, identify symptoms, what could be potential causes, and useful troubleshooting skills to be able to perform research to find information quickly. And so basically, you're going to learn as much as you can about what's the potential causes. You're going to want to make, of course, physical inspections, look and listen at devices, at software functions, at, anything within the environment that may have changed to see if there's something different. Does something sound funny when it runs? If the symptoms of the problem are no longer apparent, a basic technique is to reproduce the problem. So basically, if you can't see symptoms, is there a way of reproducing by creating a series of steps to get the issue that you're seeing? Maybe with another piece of hardware that maybe is a backup device or won't create any permanent damage, but you can recreate what the problem is. And if you can recreate the problem, you might be able to understand what's causing the initial problem and what the circumstances are. So some problems, of course, are intermittent. They may happen every once in a while. Some may be persistent and be happening all the time. Checking system documentation, installation, and event logs and diagnostic tools for useful information. Consult other technicians who might have worked on the system recently. There are listservs, there are Reddit groups to ask questions of. You just don't want to share too much information around your product, your location. You want to you consult the vendor documentation, web searches, and forums. Basically, as you identify systems and diagnose causes, take care not to overlook the obvious. Sometimes seemingly intractable problems are caused by the simplest things. Diagnosis requires both attention to detail and willingness to be systematic. Often, something you won't necessarily always have a strong understanding about the function and the proper function of something unless you have a good idea of the systems at work. So you want to rewind your experience with the device and see what could be something obvious that we're not thinking about. I think that's really important. Things that you know are not causing the issue because you have determined that. And then by looking at that comparison of types of causes, you can start to develop a theory based on what's on one side of that list versus another. Hardware or software related, hardware subsystem is affected. That's the desk. And then test the theory, particularly if you know it's an issue that happens all the time. Negate the most common fix and then even have a strategy for the second most common fix. You're going to eliminate some issues. So establishing a new theory or escalating. This is when, basically some of the things you've tried haven't worked or you haven't been able to proven by test or research that you take. You have to establish a new theory. And to do that, you need to take your thinking to another level. If the problem is particularly intractable, you can take the system down to its base configuration, the minimum need to run. When or if this is working, you can then add peripherals or devices or sub-software subsystems one by one, testing after each one until eventually the problem is located. This is time consuming, but it may be necessary if nothing else is providing a solution. It also may be necessary if it's a widespread problem and you have some time to troubleshoot the issue. You may want to do it with one device. And if you can replicate the problem with one, and that problem is something that's repeatable, you can spend focused time instead of thinking about all the devices, focus on the one issue and see if you can solve it on the one and then replicate the solution. If you cannot solve a problem yourself, it's better to escalate. So escalate is definitely a great term here that you're going to see all the way through CompTIA A. It's basically saying, this is an IT issue that we need to bring to a higher level of permissions or known assistance. So, you may be working as an entry level IT tech, but may not have expanded permissions in your environment. And what that's going to mean is that you need to escalate or turn that ticket or that support issue and push it up to someone who has higher privileges or someone who can look at the issue differently than maybe you can in order to basically get another look at what's causing it. Often an expert and senior staff to assist in problem management. But you're probably not going to be removed from the ticket. You're probably still potentially going to have some additional support for the person who you're working with on that ticket. So it's not like you're just going to give up on that. And the person you escalated to is going to have a lot of questions for you around what potentially is the issue that you've seen up until the point until they escalated it to you from you. Formal escalation routes depend on the type of support service you are operating in terms of any warranties or service contracts that apply. Some generic escalation routes include senior technical and administrative staff, subject matter experts and developers, programmers within your company, suppliers and manufacturers via warranty and support contracts and helplines or web contact portals, other support contractors, consultants, websites, and social media. So those are all potential ways that something can be escalated. As I say here, it's also very important to understand warranties. If something's covered, it's so much easier to be able to rely on that vendor that you can send the device back to or the piece of hardware back to so that you can just replace it instead of trying to troubleshoot what the issue is. Because sometimes the issue is something that you can't fix. And to go through a very extended troubleshooting process when you know you have a warranty is essentially a waste of time. Obtain authorization for use of social media or public forums, just like I was saying, not sharing too much information. Do not disclose proprietary, confidential, or personal information when discussing an issue publicly. And this is just a tip from them here. Choosing whether to escalate a problem is complex because you must balance the need to resolve a problem with a timely fashion and the possibility of incurring additional costs or adding to the burdens of priorities that staff are already coping with. What they're trying to say here is that you may not be able to solve the issue, and by escalating it, you are involving others. So it's a problem that's complex in that you're balancing the work you've done so far with how others can help you solve it. So they just want you to think carefully around, have you taken all the steps in a very time efficient way? Because you also don't want to take too long on that entry level kind of series of troubleshooting steps before you know, escalate it if it really needs to be escalated, especially the larger the number of people that it's actually impacting. Implementing a plan of action. When you have a reliable theory of probable cause, you then need to determine the next steps to solve the problem. So essentially, you're developing a plan here. Here are three generic approaches to resolving an IT problem. Repair, determine whether the repair cost makes the best option. Replace, is something switched out? Is a drive switched out? Is how long will it take to ship? Is it something essential? Like all sorts of additional potential issues are, brought up there. A workaround. If there is not a critical demand, maybe something's expensive and you can find a workaround to get you to the next step. If the repair and replacement is cost effective, it may be best to find either a workaround or just to document the issue and move on. And it talks briefly about if something's under warranty, it's better just to return it. And you need to obtain a return materials authorization, an RMA ticket. And often with RMA tickets, those are processed relatively quickly and efficiently, where especially with warranties, an RMA basically lets them know that you need to replace the device and they send a way of shipping it back and forth. When you determine the best solution, you must devise a plan of action to put the solution in place. You have to assess the resources, time, and cost required. Another consideration is potential impacts on the rest of the system that you plan action may have. A typical example is applying a software patch that might fix a given problem but cause the other problems not to work. Totally true. And this is right here with establishing a plan of action, something that you want to, if possible, to do collaboratively to minimize impacts to other systems and have a really open conversation with other people in your organization about what the plan is so everyone knows what the impacts are. And an effective change and configuration management system will help you to understand how different systems are interconnected. You must seek the proper authorization for your plan and conduct all remedial activities within the constraints of corporate policies and procedures. So making sure that you do it with the procedures of your organization in mind. And then you implement your solution. You make the fix. If applying the solution is disruptive to a wider network or business, you also need to consider the most appropriate times of scheduling. So in order to reduce the impact to the larger group of people, you need to think about how can you reduce that impact by scheduling it at a certain time, working around people's schedules so that the daily workflow stays in place the best it can. Now, it also, documentation is also a big part here. When you make a change to the system as part of implementing a solution, test after each change. If the change does not fix the problem, reverse it and try something else. If you make a series of changes without recording what you've done, you could try to find yourself in a tricky position. Take photos of things at different stages of changes. If you are changing, I find that photos at different stages, whether it's a piece of code, whether it's off a screen or a configuration of any sort of wiring, take a photo at different stages and even email the photo to yourself with the description of the steps just so you have it. If you're in, a networking closet, just so that you understand the the changes you're making and what, just so that if you're implementing the changes and what you know might happen, you have a record and you can make an adjustment as needed. And look back at the picture and say, okay, my first time I did this, I had it set this way. Now I'm going to set it this way and see if it's different. That's what you want to be able to do. Remember that troubleshooting may involve more than fixing a particular problem. It's also about maintaining the resources that users need to do their work. So, of course, maintaining the resources, you're basically making it possible for others to be efficient at their jobs. And of course, refer to vendor instructions. They may actually have very specific instructions for some of the first tier troubleshooting with many of the issues you might encounter. Verify and document. So essentially what you're going to do is verify the functionality of the solution you put into place, and then you're going to document. Now you're going to try to use a component or performing the activity that prompted the problem. So you might want to see, can you prompt the problem to happen again? You're going to want to inspect to see whether it is properly connected or damaged, whether any status indicator lights show a problem. Disabling or uninstalling the component if it might be the cause of the wider problem. Consulting logs and software tools to confirm a component is configured properly. Updating software or device driver. So, you're basically testing to see what caused the problem initially so you can get a better understanding of that problem. And before you can consider a problem closed, you should both be satisfied in your mind that you have resolved it and get the customer's acceptance that has been fixed. That's huge because a lot of times someone will fix something. And I think we probably have all had this experience with, IT on some level, that it's important to fix it so that people can sense it's fixed and feel confident in using the technology, not, well, Bill fixed the problem and then it kept reoccurring. Because it's almost like the workaround becomes like another problem. It's another reason to contact IT. It's another reason. But people will lose confidence if you don't really address the problem and try to do the best fix possible as opposed to a workaround. And that's really what we're trying to do here is resolve it to the customer's satisfaction, which could be the people you work with. It could be different departments in a workplace, that if you do a systematic fix, it's really fixed. Implement preventative measures. Really what they're saying here is if you've truly solved a problem, you've also implemented something to help prevent the problem from happening. Maybe if you're continuing to have issues with, laptop drives, you're upgrading the drive. If you continue to have an issue with multiple parts of a specific device, maybe you're buying a new type of device. Um, what, or maybe something, maybe some of the projectors need to be blown out or dust removed, or even from a computer lab. You're going through and making sure that those measures are taking place to be able to reduce the number of problems within your system. And of course, documenting findings, actions, and outcomes. Most troubleshooting takes place within the context of a ticket system. This shows who is responsible for any particular problem and what its status is. This gives you the opportunity to add a complete description of the problem, its solutions, findings, actions, and outcomes. This is very useful for future troubleshooting, as problems fitting into the same category can be reviewed to see if the same solution applies. Troubleshooting steps can be gathered into a knowledge base or frequently asked questions of support articles. It also helps to analyze IT infrastructure by gathering statistics on what types of problems occur and how frequently. The other part of the log is that it demonstrates what the support department is doing to help the business. A big part of this is also making sure that you are really learning what's solving problems, and also communicating who's solving issues, working with others, and also sharing how things can be improved. And that's an important step in any organization, an important step with verifying and documenting, understanding and sharing knowledge within your organization to improve the long-term outcomes. And I think what you'll find is that the people that care the most about the work they do will spend the time to do this process. Well, whether it's formally or informally, they'll either spend it like on the scene troubleshooting and kind of kicking ideas around and kind of lightly documenting, but at the same time, knowing that it's going to have a valuable, impact. So it's a process that you want to build in and understand that it's an important part of IT work. So that's the 3A section. The next area of this is 3B, configure BIOS and UEFI. And it's a core 1 exam objective. Given a scenario, install and configure motherboards, central processing units, CPUs, and add-on cards. So this is basically after we've learned what those parts are. Now we're going to learn a little bit more about the configuration of those parts. The motherboard firmware provides a low-level interface for configuring PC devices. It verifies that the components to run an operating system are present and currently working, and provisions a trusted environment for various security functions, the function of the device. You often need to use this system setup program when troubleshooting to check or modify firmware settings. So, firmware is specialized program code stored in flash memory. Firmware is distinct from software because it's very closely tied to the basic functions of a specific device type and model. PC or system firmware provides low-level code to allow PC components installed on a particular motherboard to be initialized so that they can load the main operating system software. For many years, the system firmware for a PC was called the Basic Input-Output System, and newer motherboards use different kind of firmware called Unified Extensible Firmware, UFI. So Basic Input-Output BIOS, legacy 32-bit firmware type that initializes hardware and provides a system setup interface for configuring boot devices and other hardware settings. Unified Extensible Firmware interface is a type of system firmware providing a support for 64-bit CPU operation at boot, full GUI and mouse operation at boot, and better boot security. And here we can see system settings can be configured via the system firmware setup program. The system setup program is accessed via a keystroke during the boot on process, typically when the PC vendor's logo is displayed. The key combination used will vary from system to system. Typical examples are escape, delete, F1, F2, F10, or F12. One issue with modern computers is that the boot process can be very quick. If this is the case, you can shift-click the restart button from the Windows logon screen to access UEFI boot options. So here's a navigation to the legacy BIOS setup program using the arrow keys. Escape generally returns you to the previous screen. So this is the setup screen in the BIOS setup program. And then you have the UEFI setup programs use a graphical interface and have mouse support. So on that previous screen and that initial BIOS interface, there's, you're clicking and using up and down arrow keys to move around to navigate. Now here on the UEFI setup programs, you can use a mouse. So many advanced menus may still require the keyboard navigation. This one's from an Asus Tech computer. So boot and device options. So I'm going to click here on the definition of boot options. This is a disk or network adapter device from which an operating system can be loaded. Defines which. This is a good line here. One of the most important parameters in system setup, so parameters is like the range of things that needs to be done, is the boot option sequence or boot device priority. This defines the order in which the system firmware searches for systems, the firmware. This defines the order in which the system firmware searches devices for a boot manager. So it's looking for a location to boot from. So here are some options. So there's the screen as the boot mode, the boot sequence. And then here we have the choices of typical places to boot from. We have the fixed disk, which could be a hard drive or an SSD. A SATA boot disk should generally be connected to the lowest numbered port, but it's usually possible to select the hard drive sequence if multiple fixed drives are installed. An SSD attached using SATA will be listed with SATA/AHCI devices. An SSD installed as a PCIe add-in card or the M2 interface will be listed under NVMe. There's also the optical drive. If you're performing a repair installed from the optical media, you might need to make this device the highest priority. So basically, if it's something that's on a disk, you have USB. Most modern systems can boot from a USB drive that has been formatted as a boot device. This option is often used for OS installs and repair utility boot disks that are too large to fit on optical media. Network PXE uses the network adapter to obtain boot settings from a specifically configured server, so it's getting it over the network. And then here you see the options: SATA optical device, embedded NIC, and a hardware drive C slot 1. What you also see here is the up-down arrow select option, kind of for that window, and how to select using enter to these different categories, which can kind of be useful if you've never been in there. And then we have USB permissions. So if I click on a feature of a system setup allowing USB ports to be disabled. The reason why I go to the vocabulary first is that's generally the key term that's the focus of the paragraph and section. So the USB feature of a system allowing setup of USB ports to be disabled. So as well as a boot device configuration, there will be enabling and disabling configuring controllers and adapters provided on the motherboard. This provides a way of enforcing USB permissions. On many systems, allowing the connection of USB devices is a security risk because if someone were to just come by and put a device in, they could do some damage if it was connected. The setup program might allow individual ports to be enabled or disabled. So you actually have the ability here to disable or unlock different ports to connect through the security tab. There are fan considerations. Most cooling fans can be controlled via system settings, typically under a menu such as cooling, power, or advanced. This menu will represent options such as balanced, cool, fans run harder, quiet, reduce fan speed, and allow higher temperatures, fanless, and custom. There will also be settings for minimum temperature, which is the value at which fans will be starting to cool the system. Duty cycle settings are used to control the frequency of power pulses to keep the fan running. A high percentage makes the fan run faster. And there are many third-party utilities that can access these settings and monitors within the OS. So just a note on that. So here we have the page on boot passwords and secure boot. So a boot password feature of the system setup. This is a feature of the system setup that prevents the computer from booting until the correct user password is supplied. A supervisor password restricts access to the system setup program. So a boot password requires the user to authenticate before the operating system is loaded. Different system software will provide different support for authentication methods. There are usually at least 2 passwords, although some systems may allow for more. We have the supervisor administrator setup, protect access to the system setup program. Then we have a user system, lock access to the whole computer. This is a very secure way of protecting an entire PC as nothing can be done until the firmware has initialized the start of the system. You must tell everyone who uses the PC the password, which weakens the security considerably. This option would only be used on workstations and servers that aren't used for interactive login, so fewer users, such as computers running monitoring or management software. So there wouldn't be, it would be limited access to something that people are all using just in a very specific way. So here we have system password not enabled as a setting. And then secure boot, which is a very popular computer term, feature of UEFI that prevents unauthorized processes from executing during the boot operation. Secure boot is a feature designed to prevent a computer from being hijacked by malware. Under secure boot, the computer firmware is configured with cryptographic keys that can identify trusted code. This system firmware checks the operating system bootloader using the stored keys to ensure that it has been digitally signed by the OS vendor. This prevents a bootloader that has been modified by malware or an OS installed without operation from being used. Trusted platform module. So encryption products make data secure by scrambling in such a way that it can only be subsequently be read if the user has the correct decryption key. This security system is only strong as long as access to the key is protected. UEFI-based systems provide built-in secure storage for cryptographic keys. Then we have trusted platform module. So this is a specification for secure hardware-based storage of encryption keys, hashed passwords, and other user and platform identification information. And I know that is one of the practice questions, what a trusted platform module is. And the additional information here provided is a specification for hardware-based storage of digital certificates, cryptographic keys, and hash passwords. The TPM establishes a root of trust. Each TPM microprocessor is hard-coded with a unique, unchangeable key referred to as the endorsement key. During the boot process, the TPM compares the hashes of key system, state data, system firmware, bootloader, and OS kernel to ensure they have not been tampered with. The TPM check is a secure storage area that the disk encryption program, such as a Windows BitLocker, can write its keys to. The TPM can be enabled or disabled and reset via the system setup program, though it is also possible to manage it from the OS as well. So here we have the TPM security on with pre-boot measurements. And then we have hardware security module, an appliance for generating and storing cryptographic keys. This sort of solution may be less susceptible to tampering and insider threats than software-based storage. And just to read a little bit there, it is also possible to use a removable USB thumb drive to store keys. This is useful if the computer does not support TPM as a recovery mechanism in case the TPM is damaged or if a disk needs to be moved to another computer. So now we're quickly moving into topic 3C. And just to kind of give you a review of what's left here, we have topic 3C, troubleshooting power issues, troubleshooting post issues, troubleshooting boot issues, troubleshoot drive availability, troubleshoot drive reliability and performance, troubleshoot RAID failure, very popular one. Then we're into topic D, troubleshoot system and display issues, which is another different core exam objective. And then troubleshoot the component issues, troubleshoot performance issues, troubleshoot inaccurate system date time, troubleshoot missing video issues. And then it goes to lesson 4, troubleshoot boot and disk issues. So the core 1 exam objective here is given a scenario. Now we're going to learn how to troubleshoot them a bit deeper. And also given a scenario, troubleshoot and diagnose problems with storage drives and RAID arrays. Troubleshooting a PC that will not boot is one of the most common tasks for a PC technician to undertake. We need to diagnose causes related to power, motherboard components, or disk issues for common symptoms. So that's just kind of the beginning of the story with troubleshooting issues with devices. So in terms of troubleshooting power issues, PC components need a constant, stable supply of power to run. If the computer will not start, it is likely to be due to a power problem. If the PC suddenly turns off or restarts, power is a common cause. So we have when a computer is switched on, the power supply unit, PSU, converts the AC input voltage, VAC, to DC voltages, VDC. DC voltage is used to power the motherboard components and peripheral devices. PSU supplies 12-volt power immediately, and the fans and hard disk should spin up. The PSU then tests its 5-volt and 3.3-volt supplies. When it is sure that it is providing a stable supply, it sends a power good signal to the processor. To diagnose no power systems, check if the LEDs on the front panel of the system case are lit up and whether you can hear the fans. A power issue might arise due to a fault in the PSU, incoming electricity supply, power cables, connectors, or fuses. To isolate the cause of no power, try the following tests. Check that the other equipment in the area is working, maybe a fault in the power circuit or a wide or complete failure, a power blackout. Try plugging another piece of known good, basic electrical equipment such as a lamp into the wall socket. If it does not work, the wall socket is faulty. Get an electrician to investigate the fault. Check that the PSU cabling is connected to the PC and the wall socket correctly and that all switches are in the on position. Try another power cable. There may be a problem with the plug or fuse, particularly with PCs. They can kind of go. Either the PSU is underpowered and you need to fit one with a higher wattage rating, or the device is faulty. If you can ensure a safe working environment, test the PSU using a multimeter or power supply tester. So here's the multimeter connected to the power supply. Test the power of the power supply. You must take appropriate safety measures before testing a live power supply. PC power supplies are not user serviceable. Never remove the cover of a power supply. If you cannot identify the fault, then the problem is likely to be faulty motherboard or power supply. If you suspect that the power supply is faulty, do not leave it turned on for longer than necessary, and do not leave it unattended. Keep an eye out for external signs of problems, for example, smoke or fire. Turn off immediately if there's any unusual sights, smells, or noises. And just food for thought there, like anything like that may potentially smoke or being plugged in may make the problem worse, just make sure you unplug it. Remove that heat coming in through a power source if you're not sure of the function of the device. Troubleshoot post issues. Once the CPU has been given the power good signal, the system firmware performs a power on self-test post. The test routine built into PC firmware to confirm that the system components are available at the boot or to signal an error condition via a beep code or on-screen message. The post is a diagnostic program implemented in the system firmware that checks the hardware to ensure that the components required to boot the PC are present and functioning correctly. On modern computers, the post happens very quickly to improve boot times, so you are unlikely to see post messages. Also, the PC is likely to be configured to show a logo screen and will only display messages under error conditions. If power is persistent, you can hear fans spinning, for instance, but the computer does not start. There's a black screen and there are no beeps from the internal speaker. It is likely either that the display is faulty or the post procedure is not executing. Assuming that you can rule out an issue with the display, to troubleshoot post, try the following test and solution. Ask what has changed. If the system firmware has been updated and the PC has not been booted then the system firmware update may have failed. Use the reset procedure. Check cabling and connections, especially if maintenance work has been performed to the PC. Coming incorrectly orientated storage adapter cable or badly seated adapter card can stop the post from running. Correct any errors, reseat adapter cards, and then reboot. Check for faulty interfaces and devices. It's possible that a faulty adapter card or device is halting the post. Try removing one device at a time to see if this solves the problem, or remove all non-essential devices, then add one back at a time. Check the PSU. Even though the fans are receiving power, there may be a fault that is preventing the power signal from being sent to the CPU, preventing post. Check for a faulty CPU or system firmware. If possible, replace the CPU chip with a known good one or update the firmware. And then here are the codes for the original IBM PC in terms of post beeps. So one short beep is, well, I'll just read the definition here. During post, errors in the hardware or the system firmware data can be brought to the attention of the user by beep noises. Each beep code is able to draw our attention to the particular fault with the hardware. It was once customary for a computer to beep once to indicate the post had been successful through most modern computers boot, though most modern computers boot silently. So here are the original IBM PC boot beep codes. One short beep is a normal post. System is okay. Most modern PCs are configured to boot silently, however. Two short beeps, post error, error code shown on screen. No beep, power supply motherboard problem or faulty onboard speaker. Continuous beep, problem with system memory modules or memory controller. Repeating short beeps, power supply fault or motherboard problem. One long, one short, motherboard problem. One long, two or three short, video adapter error. Three long beeps, keyboard issue. Check that a key is not depressed. Some PCs will not boot if a key is stuck. Check that nothing is resting on the keyboard, is clogged with dust or sticky liquid, cleaning it using approved products such as swabs and compressed air blowers. So those are troubleshooting boot processes. Here we go with the troubleshooting the boot issues. Once the post tests are complete, the firmware searches for devices as specified in the boot sequence. If the first device in the sequence is not found, remember there's a sequence, the system attempts to boot from the next device. For example, there's no fixed disk, the boot sequence checks for a USB attached drive. If no disk-based boot device is found, the system might attempt to boot from the network. If no boot device is found, the system displays an error message and halts the boot process. If the system attempts to boot from an incorrect drive, check that the removable drives do not contain media that are interfering with the boot process and that the boot device order is correctly configured. If a fixed device is not detected at boot, try to check that it is powering up. Drive activity is usually indicated by an LED on the front panel of the system unit case. If this is inactive, check that the drive has a power connector attached. If the PC has no LEDs, or you suspect that they may be faulty, it is usually possible to hear a hard disk spinning up. Once you have determined that the drive is powering up, try the following. Check that the data cables are not damaged and that they are correctly connected to the drive. If the drives are connected to the motherboard port, check that it has not been disabled by a jumper or via system setup. Troubleshooting boot sector issues. If you can rule out the issues with the power and the cabling, suspect an issue with the device's boot sector and files. Corruption due to faults in the disk unit, power failure, incorrect installation of multiple operating systems, which can happen a lot, or malware prevent the disk from working as a bootable device, a boot device. There are two ways to formatting the boot information, MBR and GPT. In the legacy master boot record, MBR scheme, the MBR is the first sector of the first partition. Partitions allow a single disk device to be divided into multiple logical volumes. The first sector contains information about the partitions of the disk, plus some code that points to the location of the active boot sector. That's where the memory is going to be stored. The boot sector is located either on the sector after the MBR or the first sector of each other partition. It describes the partition file system and contains that code that points to the method of booting the OS. Typically, this will be the boot configuration data, BCD, stored for a Windows system or a Grub or Lilo Linux boot managers. Each primary partition can contain a boot sector, but only one of them can be marked active. With the modern globally unique ID, GUID, partition table, GPT boot scheme, the boot information is not restricted to a single sector, but still serves the same basic purpose of identifying partitions or OS bootloaders. Whether the disk is using an MBR or GPT partitioning screen, damage to these records results in boot errors such as boot device not found, OS not found, or invalid drive specification. If this problem has been caused by malware, the best way to resolve it is to use the boot disk option in your antivirus software. This will include a scanner that may detect the malware that caused the problem in the first place and contain tools to repair the boot sector. If you don't have the option of using a recovery disk created by the antivirus software, you can try to use the repair options that come with the OS setup disk. And just a few items here is, of course, this is the ways of troubleshooting this boot device not found error or OS not found. Now you kind of understand why that happens. And here's some key vocab like the globally unique ID, partition table, boot scheme, GPT, the legacy master boot record. Some good vocab here. And then we have troubleshoot OS errors and crash screens. So if a boot device is located, the code from the boot sector on the selected device is loaded into memory and takes over from the system firmware. The boot sector code loads the rest of the operating files on the system memory. Error messages received after this point can usually be attributed to software device driver problems rather than physical issues with hardware devices. It will display a blue screen of death, a BSOD. This typically indicates that there is a system memory fault, a hardware device driver fault, or corruption of operating system files. Use a camera to scan the quick response QR code and open the URL with further information. The error should also be written to the system log with bug check as the source. From the event description, use the first hex value, such as 0 times 0A, to find information about the event online. The system will generate a memory dump that you can forward for analysis if you have a support contact. If there is a serious fault, a Windows system will display a blue screen of death. This typically indicates that there is a system memory fault, a hardware device driver fault, which is a small piece of software for the hardware, or corruption of the operating system files, so the files that kind of keep the operating system organized. That's when you get a blue screen of death. They give you the QR code to help you troubleshoot and identify, what the issue might be and take it from there and go back and see what has caused the blue screen of death and preventing the Windows PC from booting. A blue screen of death is a proprietary crash. A blue screen of death is a proprietary crash screen. A Mac OS system that suffers catastrophic process failure shows a spinning pinwheel of death, also called a spinning weight cursor. Linux displays a kernel panic or something has gone wrong message. So I think this is where we're going to pause now and take a break from the troubleshoot right at the point of troubleshoot drive availability. What we have left here is troubleshoot drive availability and performance, troubleshoot RAID failure, and then we're into the final section of 3D, troubleshoot system and display devices with the core exam objectives, given a scenario, troubleshoot problems related to motherboards, RAM, CPU, and power, and be able to troubleshoot video, projector, and display issues. So what I'll do in the next video, part 2 of lesson 3, we'll pick up right where we left off here at the end with the blue screen of death and the proprietary crash. And we'll begin with troubleshoot drive availability in the next video. So I hope to see you there, and we'll continue to explore lesson 3.